So I think we're going to go ahead and start. It looks like we have a really great group to start with. So I just want to say good morning to everyone. My name is Donna Ball, and I'm the lead scientist for the South Bay Salt Pond Restoration Project. And we're always excited to share the science that's happening on the project, and we do that through a variety of ways. We have regular stakeholder meetings. We share science on our website. We had a science symposium last spring, and then we do presentations such as these to share all our information. So today we're really excited to have Brian Fulfrost from Fulfrost and Associates, and he's going to be sharing his results on work that he's done on 2 studies that are related over the past 10 years, and that's to map habitat in the South Bay. This work is of interest for a lot of people, but I think it's especially of interest to the South Bay Salt Pond Project because it informs our adaptive management plan and the objectives that we have relating to targets for tidal marsh establishment and sediment dynamics. So I hope you all enjoy the presentation today. I'm going to turn it over to Brian. He's going to share his presentation, Habitat Evolution Mapping Decadal Update 2019 and 2021. And I just want to ask people to hold their questions and comments to the end. You can go ahead and put them in the chat, but he has a lot of ground to cover. And so we'd like to hold questions till the end of the presentation. So with that, I'll turn it over to you, Brian.
Thank you, Donna. I'm going to get right to it just because I, as usual, have way more slides than I should. So good morning, everybody, right away. As Donna explained, I'm going to be talking about the results of the Habitat Evolution Mapping Project 2.0, both our results from 2019 and 21, as well as our change analysis with our first project from 2009 and 11. I'd like to thank all our sponsors and funders and partners that are shown here, which are all crucial to making this project happen. And for those I've forgotten, I apologize. And for those who were directly involved in the report, Noah Young, who was crucial, assisting with the GIS and remote sensing, and David Thompson and Matt Hinshaw, who were the lead biologists and field biologists for the project. So I'm going straight to it just because there's a lot to cover. First thing is the study area. The study area is shown here and with the black line. Within that are the 3 major restoration units for the South Bay Salt Pond Restoration Project, highlighted in yellow. And we're looking at the 2021 false color image from the WorldView 2 satellite. I have this just to highlight that study area. Let's see if I can get my fancy animations to work here, which is, we're looking at the 2021 results, which are not enormously useful at this scale. It's very hard to see them. One thing I just want to point out, although we mapped everything within that, that black boundary is our study area boundary, we're really only focusing on the marshes and mudflats within that area. And so things like ponds that were full of water are not mapped because there's not much to map. So just kind of highlighting that from the beginning. So we completed our 2021 habitats. We also completed the 2019 habitats. And for those who might have gone to this symposium earlier this year, there isn't that much of a change from that, but there are some additional materials to be shown here, and that were in the report. See if we can get this clicking to work here. So as I said before, we mapped the mudflats and marshes south of the San Mateo Bridge between 2009 and 11. We mapped about 15,000 acres of salt, brackish, and freshwater vegetation. And then in 2016, we mapped about 18,000 acres of tidal mudflats with WorldView 3 imagery. Here I'm showing the 2011 habitats results with the 2016 mudflats. As part of this project, we edited and updated some of the 2009 to 11 data, dealing with some issues and errors that we found. And that data is also available. So there's going to be some slides here just because I think we have a broad crowd. And what were the goals of both HEMP 1 and 2.0 goals? The one big one was to track the evolution of tidal marsh habitats, both the vegetation and mudflats, specifically focusing on the restoration units and the restored ponds, but everywhere south of the San Mateo Bridge. We mapped those habitats as vegetation alliances and associations using methods developed in the Manual of California Vegetation and the California Native Plant Society. And we were, although we focused on floral colonization of restored ponds, we did map vegetation everywhere south of the San Mateo Bridge. We also mapped the extent and distribution of mudflats, and where we could, the presence and distribution of biofilm. We also mapped other abiotic habitats of upland vegetation, including invasives like pepperweed. We ideally wanted to distinguish between invasive and native cordgrass, but unfortunately did not have time as part of this project, but are very excited to try to do so now that the results are done. How did we do this? I'm not going to focus on this, although I, being a methods person, could spend this whole time talking about the methods. If we have questions, we can come back to this slide, but the basis for our work is high resolution spectral analysis of multispectral satellite imagery, and then extensive ground truthing, including the development of the habitat classifications we used, which we did in the first phase between 2009 and 11. And what imagery did we use, which I'll just highlight? We used Worldview 2, an 8-band, half meter, pan sharpened for both 2019 and 2021. And back in 2009 and 11, we used the Iconos satellite, which was 4-band and about 1 meter. So I'm not going to detail a lot of this stuff, but we developed a model for mapping mudflats in our 2016 study that uses all standard methods for delineating the mudflats. The big challenge here with the imagery is getting it the tide, mean lower low water, to capture with the satellite around noon, which we were pretty successful at doing. There it is. So we have about 19 mapped classifications across the salt, brackish, and freshwater marshes, and including upland and non-vegetated classes, abiotic classes. We've grouped them a lot in the report according to broader habitat types for ease of reviewing the results, but we also provide them both in these broader habitat categories as well as by the mapped habitat classes themselves. And I'm trying to get to the cool pictures and results. So here's the image from 2019, the satellite image in false color, where we're showing near infrared reflectance, which gives us the idea about healthy vegetation. Although it's blocked a little by my zoom thing, we got this image at right under mean lower low water. It was perfect for both mapping the tidal mudflats as well as the vegetation within the study area. And we did extensive ground truthing. We did about 200 surveys, which were ocular surveys with radiuses based on the Releve method that the CNPS has promoted. And we did a number of calibration surveys as well throughout the study area that were stratified throughout the study area. And that data is also available by request. And we also got a good image in 2021. The image here we chose based on recommendations from the talk on our preliminary results from 2019, thanks to Marilyn Lada and other people at ISP. We tried to push the image back as far as we could, which wasn't as far as we would want, which was June 15th. That was at the expense of capturing during this higher tide. And we thought that was okay because we captured the mudflats at such a low tide during 2019. So we don't depend on 2021 for full extent of mudflats, and that's shown here, although it's pretty good. It's about a 0.6 foot difference, which is a lot. We also did extensive ground truthing in 2021. Oddly, the exactly same number of validation surveys, which is just a coincidence. We did quite a bit. We did a little more calibration because we also made some changes to our preliminary 2019 results. So we got quite a bit of ground truthing data. I can click on this. And before I go into the results, we did a standard error matrix and kappa statistic. And I'm only showing here the overall. The takeaway here is we more than met our 70% target for overall accuracy and improved upon our results from HEMP 1, both at the Sub-Dominant Habitat Association and Dominant Habitat Alliance. So we're happy with these overall results. I don't present the error matrix for the individual classes, but those are in the report. And so here these are the slides that you're not supposed to do, which are all full of text. So, so I'm breaking those rules right away. I understand if you gloss over for a moment, but I just wanted to go through some bullet points about what our conclusions are before I start showing you some of that information. And so, one of the key things to take away is that the acreages of salt, brackish, and freshwater habitats have almost all increased since the first project within the restoration units and restored ponds. Although a few have fluctuated, we had some mixed results with certain habitats, but none have decreased below 2009 levels. One thing that I think we got a little like, people were saying, well, that makes sense, or duh, in my previous talk to a smaller group, was that the rate of floral colonization that we found between the 2 years, between 2019 and 2021, was in some way greater than the rate of colonization that happened between 2011 and 19 in many restored ponds. And I think that likely is because of those places have accreted enough sediment where the colonization is starting to take off, which is a good sign. And I like it when people say, duh, Brian. That means there's some calibration with the work we're doing. It's meeting those people who are down and very aware of what's going on in the ponds. As far as the mudflats goes, although we found about a 4% decrease, we only have 2 data points for mudflats, really, the 2016 data, which wasn't a direct part of this project, and then our 2019 mudflats. There was about a 4% decrease within the bay exposed mudflats and sloughs. That decrease, I think, is misleading. There's innate variability in what we're doing. Plus, when we looked at the extent and distribution, it's very similar to the mean lower low water line produced by the USGS, Amy Fox Grover and Bruce Straffe in 2005. In fact, we see areas where that, in fact, might be accreting a little. So we don't see a big change in the mudflats at all. And then one, I think, obvious thing for anybody who does spatial analysis or mapping, but it's really important to point out that the direction, whether it's positive or negative, or the size of change in habitat acreages really varies at the different geographic scales that we've summarized. We summarized at 3 scales: the study area, by restoration unit, and then by restored pond or select marsh. And that trend or direction of trend varies based on geographic scale or even temporal scales. So just like we've seen the rate of increase in the restored ponds, that rate is looks different in a 2-year period than it might in a 10-year period. Okay, great, Brian. So what are some of these results? One thing I think to take away is I presented all the stuff for the study area. I think these values are useful, but maybe not as useful than the information we've provided and data within the restoration units and within the restored ponds, partially because there's a lot of influencing variables and they might hide some things. So it's good to take that into account. But it's important to note that we still see about a 3% increase in all the salt marsh species between 2009 and 2021. That's everywhere south of the San Mateo Bridge. We saw a doubling of cordgrass and cordgrass pickleweed during that same time period. Although, and here's where the scale makes a difference, although the pickleweed acreages are nearly identical between 2009 and 2021, there were significant increases within the 2 restoration units, Alviso and Eden Landing, up to 35% increase in pickleweed during this time. We have a more muddled or mixed signal for our high marsh species. And you're seeing some of that mixed here. If we compare 2009 to 2019, there's about a 10% increase. We compare it to 2021, where we think we've mapped gum plant really well. There's about a 10% decrease. So some of that is the mixed results we're getting and also fluctuations. But we think we still have a very good, we're mapping the distribution and extent of gum plant very well, especially in 2021. And then we saw about a 20% increase in the acres of alkali bulrush. And as many pointed out here, we see a kind of cyclical trends in the acreages of bulrush over time. Other things that are notable, we saw a very large drop in pepperweed between this time, up to 85%. even if we're under mapping pepperweed, which we potentially are, we definitely think there is a significant decrease in the density of pepperweed throughout the study area. But there's also at the same time a 4 times increase in spear scale, which we also think could be cyclical. So that's all between the 2 time periods of the project. To focus in on the time period of HEMP 2, which is 2019 to 2021, the interesting thing we found is 617 acres of direct floral colonization of mudflats. That's mostly pickleweed and spartina. 90% of that is within the ponds, mostly in the marshes. So we're seeing direct floral colonization of mudflats, and especially that seems to have increased in the 2 years of the most recent study. There was about a 7% increase in pickleweed, which was slightly bigger in Eden. We saw quite a big increase in colonization, and oddly a 20% decrease in bulrush. I think that's more phenological than anything. And when at the time of satellite flyover, a lot of the alkali bulrush, specifically the maridamus, was decomposed, and so unfortunately didn't capture it fully. Could be indication of other things, shifts in salinity that could be cyclical. Okay, so I'm trying to rush to these pretty pictures because there's plenty to go through. And so here are our mudflats results from 2019. They're shown in orange. We have the USGS, Fox-Grover Jaffe 2005 mean lower low water line, which they used to map the extent. The one thing to take away is our mudflats comply very well with the other this mean lower low water line from 2005. So although we have our own internal calibration and validation measures, it's another one. And one thing to point out, especially if you look north of the Dumbarton, it's kind of hard to see at this scale, but there's even a potential increase. The mudflats might be extending slightly out into the bay. And if anybody knows that area out there, it's extremely shallow. So this isn't, so the amount of sediment, although I'm not a hydrologist or a hydrogeologist, it's accreting on these very, very, very almost flat mudflats out there. So we don't see this huge decrease or drop in mudflat despite the drop in acreages. And here's our 2016 mudflats. And again, not directly part of this project, but important. And they're very, very similar to the 2019 results, especially in the bay and exposed sloughs. One thing to note, which we note in the report, is we see a decrease in mudflats within the ponds, which you would want to see at the same time you're seeing floral colonization of those. I don't know how to click. Okay, and so here's just a table of those acreages. We're not really comparing to 2021 because we captured it at a higher tide. One thing we noted, I just calculated the difference between 2019 and 2021 based on that tidal difference, which was about 2,000 acres, right only on the bay. That'll tell you what a 0.6 foot difference in tide can make, quite a bit. And if you just conceptually add that to our total, it would make it to about 18,000 acres, which is similar to the 2 other data points we have. And so, I think we need more data. 2 data points isn't enough to actually see a trend. So I don't want to say too much about that or put too much emphasis on it. But we certainly don't see this mass erosion of mudflats or anything like that. Okay, here's way too many graphs for you to take in. So I'm going to focus now on the results for Eden Landing. And here on the left, I have the overall results between 2009 and 2021, and all of the stuff we're going to be seeing is for the between the 2 time periods, unless I state otherwise. And one thing to note is we see an increase in all biotic species. There's about a 23% increase, 2 times plus increase in low salt marsh, such as cordgrass and cordgrass pickleweed, 29% increase in pickleweed, mostly in the mid-salt marsh, and 2 times increase as well in high marsh. And over on the right, we have the graphs for Mount Eden Creek Marsh and North Creek Marsh. One thing to point out, and we see this sort of trend over time. One thing to point out is the increase between 2019 and 2021, which are the 2 rightmost bars. It's quite a big increase especially when you compare to the 8 to 11 year difference between 2009 and 11. Certainly it's increased between the time periods of the projects, but that rate of increase seems to have gone up quite a bit. And especially we think here in Eden Landing. And I like the duh, like, well, it's accreting there, Brian. Well, those are correlative measures that say we're certainly doing the right thing, or the results seem good. So because I make maps for a living, I like to get to the maps. This is all an excuse just to get to this point. So here we're looking at North Creek Marsh and the development of the floral colonization of pickleweed and cordgrass from 2009 on the top left to 2021 on the bottom right. And to me, this is a sign of success that the marshes has really developed there over this period. One thing to note is that in the southern part of the marsh, it hasn't. And I think this is because I was told that that's because that was deeper and it's taking potentially more time for sediment to accrete there. But I really see this as success, perhaps of the mapping, but also of the restoration itself in this marsh. And people can chime in and give me their opinion, but there's a marsh there that's formed. And we know it's not the only place, but we certainly see it here in North Creek. And also E9 and E8 and E8X, which were actually fully open to tidal action after HEMP 1. So we don't really have much to compare from the first project. And here's 2021, E8A's developed quite a bit into a marsh, and E9 less so. You know, one thing to note at this scale, it's hiding the sort of spotty pickleweed and cordgrass that are very hard to see, which if you zoom in are there. So we're seeing those sort of larger accumulations at this scale. But definitely E8A has developed quite a bit more. And this is 2019. And so we see that same thing, which I was showing in that graph. We see quite a bit of change between 2019 and 2021. And just for comparisons, this is 2011, the pond was mostly full of water. And interestingly, on the top, we have mudflat with biofilm, is that light tan. And the bottom one is bare earth. It just means it probably wasn't wet as much. And we see where the marshes have developed from 2011 is pretty much where we see this sediment was even developing in 2011. And I really wanted to show this. In the report, we have change graphics, which I think are a really good visual. To be honest, I think it was Rachel or Yvette suggested those years ago, so I just went with it. So what we're showing here is in black are what was in 2019. And so by 2019, there were about 54 acres and shown in black. But between 2019 and 2021, we had an additional almost 40 acres shown in green. So you see quite a bit of change. And that's also true in E9. In E9, we had about 7 acres by 2019, but between 2019 and 2021, we see an additional 16 acres shown here in green. Wish I could figure out how to get those two slides together, but I couldn't. So, so it's not, so I presented this work to the PMT. Somebody said, what about the marsh erosion? Which I was concerned about mudflat erosion and restored ponds, but not as focused on looking at the edges of some marshes north of the Dumbarton. And when I did, we saw, unfortunately, erosion of the marsh here at Whale's Tail, on South Whale's Tail on the left and North Whale's Tail on the right. The white line is the edge of the marsh in 2009, and the black line is the edge of the marsh in 2021. The image we're looking at is the false color image from 2021, so that's why it complies a lot with the black line. And this is up to about 150 feet in some locations. It's not a perfect comparison. There's some mudflat included in the white line, but not very much. And there's also spatial inaccuracies. Those are at most, and not here, at most up to 2 to 3. If we get closer to the urban area, it might be 4. But here, our spatial accuracy is pretty good. It's probably 1 to 2 meters at most. And so it doesn't account for that shift. The shift is definitely something we're seeing, this sort of erosion of the mudflat edge. Again, this is not the restored pond, this is Whale's Tail. We go over to Bear Island. We have 2010 on the left and 2021, I think, or 2019 on the right. You know, one thing to highlight is we're going to look at the restored ponds here. Did not focus on the acreages of the other locations, but we will in a second. The same trend is here at Bear. We see in both outer, middle, and inner Bear, we see a development of marshes happening and that rate of floral colonization increasing. Inner Bear was obviously open to tidal action much later, but is developing very, very well, it seems, from our perspective based on the map. And, you know, you can't really see much here, but at 2021, there was quite a bit of difference in those restored ponds. See if I can work this, my fancy clicking. So I'm going to zoom into some good news here, which is here in Outer Bear, the restored pond. On the left, we have, again, my screen sharing thing is hiding what I can see, but I think it's 2010. It's one of the previous years from HEMP 1. You know, we had the beginning development of pickleweed along the channels, dominated by biofilm on that mudflat. And by 2021, we have much bigger mats of pickleweed and spartina along the edge, and again, forming along where those channels were. What I'm going to highlight here, I'm going to click is, I'm going to show the difference on the right between 2021, if I can learn how to click, and then 2019, and there's quite a bit of difference there. I think I got fancy here, and I might, one of these I showed the change map. Okay, so here what I did is, I'm showing you see that increase between 2019 and 2021 on the two bars to the right is quite a bit, especially when they compared the sort of relatively linear growth that occurred up until that point. And again, I think this is what a lot of people expected in certain ponds where the sediments are accreting over time, and at some point it reaches a threshold and that floral colonization has really taken off. Uh-oh. It is not responding. Oh, there it is. Okay, so I'm learning how to click. So that's the good news. Potentially other news here on the left side, we have Outer Bear, the top line of Outer Bear, not the restored pond. And on the right, we have the middle part of Greco Island. And again, what we're seeing here in the white is the Marsh Edge from 2009, and the black line is the Marsh Edge from 2021. And we're seeing that potential erosion over time of those bay exposed marshes outside of the restoration units. And this isn't universal. See this more north of the Dumbarton. And as I'm going to show you in a second, south of the Dumbarton, we actually see marsh accretion or marsh growth onto mudflats in certain locations. So this signal isn't the same everywhere. Also, the bay exposed parts of these islands tend to have more marsh erosion than if you go into the interior, which is why I kind of showed this part of Greco. This is really true also within the Outer Bear. That is, if you get interior, the signal is not as clear. In some places, it's actually growing slightly, and the trend of erosion, if anywhere, is much smaller, which might be expected, but that's also true. Okay, so if we shift over to Alviso, we have again the graph of the whole area over here on the left. Oh, I can move this. That's great. So again, we see increase in salt marsh species, a 2.5 times increase in cordgrass, 35% increase in pickleweed. See about a 70% increase in gum plant. But again, we see quite a bit of fluctuations, and we've had mixed results with some of that gum plant. Also, similar increases in the brackish and freshwater marshes. When you zoom into some of the restored ponds, I think you're seeing trends that people really expect. Unlike the other ones, A21 was open to tidal action even before our first project. A lot of that development occurred between 2011 and 2019, although we see some growth still, and I don't think that's a surprise to anyone. However, in A6, we see quite a bit of growth, but that growth seems to have accelerated, which is a good sign for A6 between 2019 and 2021. Okay, So we zoom over here to the Duck's Head. We're looking at A6 on the left. I think this is 2011 post-breach. You have the mudflats we're developing, very small little areas of pickleweed. And, you know, in this case, we captured the image with the borrow ditch being full of water. And over here on the right, we have the development of pickleweed and cordgrass in 2021. Again, this is, it's hard to see some of the details here, but there's quite a bit, certainly not at the level of some other ponds, as I think as people assumed would happen or thought would happen. And then, you know, but again, we see, this is 2019, we see quite a bit of growth between that 2-year period. And I think I tried to get fancy here. And so here's our change graphic for that. But this is just between 2019 and 2021. In 2019, there was about 7.5 acres of pickleweeds and cordgrass, but we see 27 acres worth of growth between 2019 and 2021. And again, some of that is this spotty pickleweed, as well as sort of the development and growth of mats that were growing along channels. Okay, also, so I showed examples of marsh erosion. So here's the top of Duck's Head where we see the opposite. The top image is 2009, and the lines, the black line is where the marsh is in 2021, which is shown on the bottom. And then the yellow line is the marsh in 2019. And this is up to about 40 meters of movement of the marsh onto the mudflat there at the top of A6. The water on the top right is just the beginning of Alviso Slough. This trend is not linear. As you move west along the Duck's Head, the growth goes down to about 10 meters change. So, you know, just good to know there's some variability in that. And it's not all marsh erosion in these bay exposed mudflats. And here I'm just showing the 2019 image. So there's been growth even between 2019 and 2021. And here we have A21 in 2011. You know, I think this is better visualized with Chris Benton's amazing kite photography, but the maps don't hurt. And so we see the development of pickleweed and spartina along the channels. It was mostly a mudflat in 2011. Sorry about this, guys. And then by 2019, we had this extensive marsh, salt marsh and brackish marsh in the middle. The orange is this alkali bulrush. And that continues into 2021, which have this very extensive large brackish marsh in the center mostly. And then, and although there's pickleweed interspersed as well, it's surrounded by pickleweed and spartina marsh. Again, more success. A19, and we mapped A19 in 2021 before I think they opened the north part. I could be getting this wrong on Mud Slough and other places to more tidal action, but we still see that spike in growth between 2019 and 2021 in A19. So hopefully even those additional levee openings will help accelerate that as well. So here again in 2011, this was almost exclusively a giant mudflat with some pickleweed. And I know some people have found invasive grass. It's interesting, we were noticing some alkali grasses not distinguished here in 2011. But by 2021, we have huge amounts of spartina, big patches of spartina, pickleweed, and then also the alkali bulrush, which was a little hard to see with the tan of our color we use for biofilm, but quite a bit of change. And I did not show, but some of that change accelerated between 2019 and 2021. We see even quite a bit more floral colonization. I think I didn't create that graphic because it was a little messier with the growth in alkali bulrush. I'm doing really well on time, which is shocking. So here we're looking at marshes that are not directly being restored. A marsh that everybody knows, the Calaveras Marsh. And as I think David pointed out to me yesterday, everybody knows this marsh has been growing for a while. And if you look back at the old Eco Atlas, you can see how smaller the marsh was, even compared to when we started in 2009 up here on the top left. So even there between the time of the first Eco Atlas and 2009, there was obviously a lot of growth. But here I'm tracking the changes between 2009 and 2021. 2009 on the top left, 2021 on the bottom right. We have black lines, the Marsh Edge in 2021, yellow 2019, the sort of, Brian, why did you pick a hard color, orange for 2011, and then white in 2009. And the difference between 2009, I think, and 2021 is up to 60 meters or more. So we're seeing more of a, I think, a linear trend here as the marsh moves further and further down the mudflat. And it's dominated by huge patches of Spartina. And although I think, again, a lot of people go, oh, well, we know this. This is Ogilvie Island. And I don't know why I like this visual, but I think it really shows the trend here, 2009 on top, all the way down to 2021, the colonization of what were mostly mudflats dominated by biofilm on the west and eastern part, shown in the tan in the top image, all the way down to 2021, where now they're completely colonized. The channel in between the island and the area just south is almost completely filled in. And we see that development of the marsh extensively at Ogilvie. So that marsh erosion, which we're noticing mostly north of the Dumbarton, we're noticing in some locations south of the Dumbarton, marsh growth. So this is why the study area signals is complicated, as I think everybody here can attest. So I'm again shocked that I've come in on time here. That's the biggest shock of this whole report. But so we produce from all of this work. We have our final report, which is available at this link. I think it was also available via a link for the presentation itself. There's a summary. It includes the results for the HEMP 2019 and 2021, as well as a change analysis with HEMP 1 separately. Again, we summarized at these 3 different scales, and we included our methods and appendices, and extra tables for those who might be interested. The data is also available, the 2019 and 2021 habitats. This presentation will go online, so if you're interested, you can download that. And we've also updated the HEMP 1 habitats with some changes. Those are also available. And I think the presentation and webinar will also be made available. And if people are interested in the ground truthing data, they can email me, which I'm gonna get to in a second. So being a good researcher, I'm just interested in more research. No, I'm kidding. With all the time and resources in the world, there's so much we would do. And it's only partially listed here. And this community here is the one that are going to ask the right questions about how that we might be able to use the data. One thing I'd really like to do is, or have done, is quantify the marsh erosion and other wetland dynamics outside of the restoration units, because I think my focus steered me away, and then looking at those erosion trends could be very useful and pretty easy to do at this point, since we've already basically done most of the hard work. Also, I think, as Pete pointed out, differentiating native and invasive cordgrass with ISP as data, which is also pretty easy darn to do. And then I'd love to create vegetation and channel polygons with the whole data set. We've already developed a method to do that. It's already done in certain places. We just didn't have time to finish it. And that is the end of my presentation, and I am available for questions. And I just want to point out to all the photos that are both in the report and shown here, thanks to David Thompson, Matt Hinshaw, and all of our field crew who I haven't mentioned, who are instrumental in the ground truthing, who are thanked in the report. This is not just a project of myself. It's been a team effort from the very beginning. And that team includes, in essence, the whole community who have provided guidance for it. So I appreciate everybody mentioned in the report or not mentioned. So.
Great job, Brian. We're starting to see some questions come in, really terrific images and the presentation and explanation. So I'll start with, Julian has a couple questions, so maybe we'll grab both of those at once. What is your guess on how much marsh has been lost due to lateral erosion, the line between the black and white lines? And are the losses offset by some of the gains, like at Calaveras? And then he also had a question about how well you were able to map Grandelia.
Okay, so I'll do that. Those are both excellent questions. Darn you with your excellent questions. So the first thing is, how much? that's what I want to answer. So I do think some of there's definitely an offsetting factor for sure. And so there's an offsetting factor both in the marshes outside of the restoration units and within, right? So how much I really feel, I don't know those numbers. I did some quick calculations, and on the surface, without doing the actual quantitative work, I think that they might offset each other, which is why that study area symbol is a little muddled, right? So but even if they do counteract each other, I think it's good to point out what are the dynamics happening. And I obviously think we've heard that this is a product of potential sea level rise, right? And wave action eroding at those marshes. But we're really would be very easy as a next step, funding permitted, to do that, calculate that, and it would not take much work at all. And sorry, I couldn't give you a number because I don't want to throw out a number that's going to be wrong. But as far as mapping Grindelia, here's the thing. I think we mapped Grindelia very well in 2019 and especially in 2021. And it was a little more mixed in the previous project. And so calculating change acreages is a bit difficult. We see a fluctuation there that probably isn't true. I think, it's easy for me to say this. I think we're good at mapping Grindelia now, and maybe weren't as good throughout the other time periods of the project. And you can see that in the report and in the data. And I'll give you an example. There are channels with Grindelia in Whale's Tail that appear in the current HEMP 2, but were absent in HEMP 1. The question is, were they there or not? People might chime in here. But we know in certain locations where we weren't mapping them in the previous and then appeared. We also have the opposite problem where we're over mapping Grindelia within the mid-marsh plain where it doesn't exist. I'm conflating this is our HEMP 1 data was based on 1 meter imagery and our HEMP 2 was based on 0.5 meter. And the larger numbers we get from HEMP 1 are partially also a result of that. So there is my mixed answer to the mixed results we got from Grindelia.
That's good. We have a lot of questions, Brian. Cass Green has excellent presentation. This may be in the report, but what are the rules you use to distinguish different habitat types from each other, from one another? And what are your thoughts on the MCV classifications for tidal wetlands?
The distinguished habitat types is a spectral analysis using supervised classification. We use maximum likelihood and a priori probabilities to influence the weights of the different signatures. So it's a very, in essence, Cass, great question, old school approach. We did not build rule sets. We used elevation as a qualitative measure for evaluating the results. And then we did do some manual editing at the end, not extensive, where we had higher uncertainties, where the spectral distances were large. And so those are the main methods that we used for differentiating. I think I'm getting your question. So the spectral differences we parsed out. And then which, as you probably know better than anyone, including myself, there's overlap there. And so we did as best we could, making those and differentiating those different habitat classes. As far as the MCV goes, we use that method of dominance to develop those classifications in a similar way as the MCV and the CMPS method. And I think they're excellent for doing remote sensing because they're based on rules of dominance and percent cover. And I think that is a good for not only automated classification, but manual classification. So I'm a big fan, continue to be a big fan of that vegetation classification method. So there's my answer to those, and I really appreciate you attending, Cass.
Thank you, Brian. I wanted to clarify my questions just a little bit. I wasn't asking about your methods.
Oh, sorry.
I was asking about, like, on the ground, what rules did you use to distinguish habitat types from each other? Or did you even develop rules? That's one. Or did you have descriptions?
That's a really good question. We did that almost exclusively in the first phase in the 2009 and 11. So we basically went out in the field and we did a series of rapid assessments as opposed to releves. And so using those rapid assessments across the study area and expert knowledge, and how did we differentiate those in the rapid assessments? Through those methods that you do based on percent cover, and separation distance is a little weird for wetland environment. So I don't remember the exact rules in my head, but we developed a series of rules about where the boundaries of these things were based on percent cover, using that data, those rapid assessments mostly that we developed during 2009 and 11.
Okay,
So,
and then on the MCV, what we found is that it doesn't really capture all the variation on the ground out there.
no.
Okay, so I just wanted to know what your experience was with that, that there are other classes out there that aren't captured in the MCV.
So you're absolutely right. And so, interesting, Cass, we mapped quite a bit more associations in HEMP 1. But the accuracy was lower than I wanted. So I did not continue those associations. So I'm equating a lot variability with at least the associations we found. There is quite a bit of variability out there, and we only could capture some of it. And so as we scaled up taxonomically, no big shocker, our results got better, right? So we reached a point where we felt like we were capturing enough detail, but not overreaching. So I think it's very difficult to capture all of the variability out there. And so you have to say, what's the goal? And does this amount of taxonomic variability capture what our goals were? And it did for us. It doesn't capture all of it, but it did for us. Like, there's stuff we're gonna miss, right? Yeah. And so in any spatial analysis, you're gonna generalize both spatially and taxonomically, right? So I hope that answers your question.
It all makes sense. Thank you.
You're welcome.
Yeah, it was a great presentation. Thank you.
Thank you. And we can continue this discussion, Cass. I'm happy to do that.
That'd be great.
So there's a question from Gwen Miller. There seems to be a bit of speckling in the images, and do you think that's reflected in the field? And is this why you're interested in creating veg polygons?
Yes. So the speckling is like sometimes, exactly right. I want to keep the speckling, which I like that word, so I'm just going to run with it, in the raster. And then when we create the polygons, we're going to lose some of that. And we already have. I mean, is anybody who's done this work here, well on our way to doing the polygons, and developed a method for generalization and done it. And so now where's the speckling real? Well, like I said, that we had some issues with the HEMP 1 data set where there's too much gunplant in the mid-marsh point. So then I was focused on that to some degree. And we noticed in one location, wait, there is Grindelia in these locations in some places, right? Not all. And so I'm using that as an example because I remember specifically little tiny patches of Grindelia we saw in the field that were showing up in the results. And I'm like, so in some cases, yes, I think we're capturing that local variability. In other cases, in that example, it might be overmapping. So, but I think generally the speckling shows us variability, that actual variability. But in some cases, it, depending on the class, might be a sign. And I think mostly in the HEMP 1 data of overmapping, and much less too in the HEMP 2.
So Amy Fox Grover, great work, Brian. Exciting to see. Regarding the 4% decrease in mudflats within the bay, do you think that's real or within the uncertainty bounds due to variability in tide levels during flights?
I think a great question, Amy. I think it's, I think it's variability is my instinct. And it's not real per se. It's not a drop. Now we get more data, we could see it. Here's one thing, 2016, I never cleaned the mudflats. What does that mean? We spent on HEMP 2, we mapped 2019, and then I spent a time improving it, some manual edits that we spent time on. We didn't have the time to go back to 2016. How much is that? It's about up to 50 acres. So there's one thing we know is a false signal, and then natural tidal variability. And so to me, it's all within the realm of where it should be. We would need a larger time series to see if that is an actual downward trend. And I don't think it is. I really don't, especially in the bay exposed mudflats, right? So I hope that answers your question. And also, I think if you look at the 2005 mean lower low water line, the mudflats are very similar and slightly bigger. So, and that hasn't really gone down in 2019 from 2016. So again, my instinct is it's not a real decrease.
Lori Hall had a follow-up on that question, indicating that mudflats decreased by 4%. How much mudflat habitat was lost in the ponds?
That's a good question. I don't, so interestingly, there was mudflat, it's in the report. I kind of want to say, between 2019 and 2021, in the ponds where we have more control, there was about 550 acres that were colonized by flora. But oddly, there was also some accretion of mudflats. So how much? We didn't calculate that other thing, but I think there was quite a bit of change. Not all of that 500 so acres was directly within restored ponds. That includes actually marshes. So that could be just variability in the image, but a large percentage of it is the change of mudflats within ponds that are being colonized throughout the whole study area. So there's also like things like signals like in Ravenswood, which I don't mention much here because we didn't see huge amounts of change, and where, by the way, we're mapping gum plant well. In there, it mapped as mud in 2016 and then didn't in 2019. So that's a reduction in mudflat that adds to that number, that muddles that number to some degree. These are all really good questions.
Yeah. John Callaway said, thanks, Brian. It'd be interesting to see lateral marsh change by region or location to see how east-west sides of the bay vary, as well as north-south and exposure effects.
Okay, when are we writing the grant? I mean, I think John is right on it. There's a spatial trend, and I can't summarize it well because I haven't, but there's definitely something happening there I'm seeing, at least qualitatively, that east-west, north-south trend, and even exterior-interior that is worth exploring. And honestly, I'm joking about a grant, but a graduate student with one person helping run that could do that pretty easily.
Very cool. So another question from Gwen. Is the satellite data expensive? And do you think using NAPE data would be sufficient, or is NAPE not the best since it's not likely taken at low tide?
I think all the imagery is useful. I mean it. The NAPE imagery is amazing. So I say that because I want us to continue to get NAPE imagery from now and into the future, because it has enormous uses to look at change over time. The satellite imagery can be expensive. I do everything I can to make it as cheap as possible for this project, which means we have slightly restricted licensing. I battered Maxar until they gave me. So it's generally expensive. And if you finagle with them, I think it's harder and harder to do that, So, it's in the realm of 5,000 to 12,000 for the study area. The advantage of this, I still think satellite high resolution, high spectral resolution, high temporal resolution imagery is useful. One of the reasons is because we can capture the tidal variability in a millisecond more so than the tidal issues you identified in NAPE. I think you can still do stuff with NAPE, maybe less for the mudflats, be aware of the issues with it. So that, having said that, but it's updated more frequently, it's free for us to use. So those are advantages right there over the satellites. So I think they both have their role.
Great. Let's see, maybe a couple more questions here. I'm wondering, Justin Simeon, I'm wondering if these data sets could be used to assess if or how pond size affects the speed of vegetation colonization, accounting for starting elevation. There were some examples shared that appeared to show quicker or more colonization in smaller ponds.
The answer is just yes.
Mhm.
There's, and that's right up, that kind of looking at shape and shape structure and size is very much that all of this data is rife to be used and analyzed in that way. And I think that's a great idea. And please email me after.
So I think we're coming to the end of the questions. I just want to point out that Ariel put a link in the chat on where to get the data sets and the reports. And then we'll be linking this video and the presentation within the week as well. So all of this will still be available for you all to reach out. And Brian's been really gracious about answering questions if people have questions on anything. I just want to thank you, Brian. This is a great presentation, and he's presented this a few times to the PMT and other interested parties, and it's just really great to see all this work. And thanks for all of your hard work and your offers to really explain it to all of us.
I appreciate that, and I am really excited. I think when you develop a data set like this, I'm more than happy to answer. I would rather people send me emails than it sit unused as much as possible. So I am really open to answering questions and to potentially future collaborations. I want to remember, I'm seeing one person I want to thank, Laura Volpe and John Bourgeois, who are very instrumental, and Donna and Dave Halsing were all very important for the development of this project. And I want to make sure that I thank them before I forget. And so I really appreciate all your support throughout the years, and it's gotten to us where we are now. So thank you.
Well, we thank you a lot, Brian. So thanks everyone for joining us today. We had really great turnout. So yeah, let us know if you have any questions, and feel free to check out these talks on the website. So thank you.
Thank you, Donna.